So I thought instead of writing this out static, I would record a video. So this is section 7.3, and this is about FDA measurements about mercury in fish, and they're trying to test the claim that the evidence that the fish in Florida lakes have more mercury than the allowable amount. So that's the claim they're making, and they're giving us some data. So let's see, they aren't telling us that this is a random sample, but I would think if they caught fish in 53 different lakes, it'd be pretty random if they caught them. So I don't know, I guess the random sample kind of bit is okay. Requirements. Okay, so now we're going to see, is the mercury level that's in fish normal? So what I did is I copied out this let's see, I copied out the data, and I loaded it onto that spreadsheet that I made you folks, and of course I pasted it in and sorted it. And what am I seeing? I'm seeing let me get a pointer going here. I'm seeing a right skewed distribution, so that doesn't support that this is coming from a normal population. I'm looking at the normal probability plot, which is plotting z-scores against the data, against the x values or against the data. So I'm seeing a little bit of non-linear behavior here, and this is dipping down a little bit. So it suggests that maybe it's not they're not coming perfectly from a normal distribution. And then when I look at the outliers too, there are no outliers. So I did an IQR test, a 1.5 IQR test, and there's no outliers. So, even though this is a right skew distribution and there's a little bit of non-linear behavior, I would say this is probably close enough to say that we can say that the amount of mercury that's coming from fish in Florida is normal. But the other issue we've got is that I've got 52 pieces of data, and that's way more than the 30 samples, n equals 30. So I think we're safe to apply, run these tests, run the t-tests on this data. So what I did is I went out to Rossman Chance applet, because you probably know that I like that applet. And I said, say allowable amount, if we look back at the textbook, let's see. It says the allowable amount is 1 milligram per kilogram of, 1 milligram of mercury per kilogram of fish. Is that what it is? So if I went out here and I said, yep, no, this HO would be, yeah, no, the mercury is within acceptable levels. It's just that, and any variation is just due to sampling error. And then here's the claim that the amount of mercury in fish is higher than that. And I let it paste in the data. It told me that the sample mean was 0.5. So if we look at the p-value of that, if we look at the sample mean was way down here, we're 0.5. So sample mean was way down here, or these are t-scores. These are t-scores. So if I take a look at, I guess I don't know quite what this graph is showing me. I'm assuming that 0.527 would fall right down. These are x values. So this is the amount of mercury, the average amounts of mercury. And then 0.5 falls way down there. Now the probability of getting a sample that high or higher, if 1 is the mean level, is 100. It's 100%. The p-value is 1. So this is a little strange. I mean, I usually like to talk about the tail area when I'm talking about test statistics and all that. So this is showing me that this is way below average. So what I would do is I'm going to try this. If I flip this around, so this is a less than tail. So we're going to make the claim is that no, the fish. So if we look at it this way, we can say that the fish in Florida have too much mercury in it, and HA would be no, they don't. And in that case, I think it'll become a little clearer. The probability of getting a sample this small a sample mean this small, if the fish do have too much mercury in them, is 0. So what we can do is we can reject, I mean, statistically we can say we reject HO, but what conclusion would we make with that? Well, if we went to one of those flow charts, let's see, where is all that? Yeah, if we go to this flow chart, hopefully you can see that. So the claim didn't contain, so did the claim, when I rewrote this, I said, yeah, the fish have too much mercury in them, so that would be HO. So that would contain equality. So it would go a yes. Did we reject HO? Yes. So then we can say there's sufficient evidence to warrant the rejection of the claim that the fish have too much mercury in them. So we're saying based on the sample that they're safe to eat. And just to compare that to what they said in the book, I grabbed, I grabbed these answers out of the back, and what they chose to do in the back of the book is they chose to do a right-tailed test, get that p-value of 1, and they're saying, so they're with the way they set this up, they said this is the claim that no, the fish are safe to eat, they don't have too much mercury in them. HA would be they do, so they're saying we can't reject HO because that p-value is so large, so that's saying that the fish are safe to eat. They do not have more than the allowable amount. Maybe that'd be the better way to say that they don't have more than the allowable amount. Maybe not say that they're safe to eat. But that's the end result. That's what people would interpret it as. Okay, so sometimes it's better to think about what you ask about. Sometimes it's better to swap the question. And as you notice, here's their claim, doing it this way. And when I switch it, so it was a less than, a left-tailed test, that became my claim. So think about it, and it's tough. This is the tough part about this idea, is how do you number crunching is easy. We get applets to do that. And that's why we still need humans to be doing this. Okay, so we can look at some more examples if you want in the forum.